Why is it so important? Application dependency mapping is important in three folds. First of all, it helps you in identifying any risks within the environment, being able to identify what are the different components and all the single point of failures within the environment. A lot of times organizations end up having single point of failures which is not unidentified until an application dependency mapping is put into place. Secondly, it helps us in identifying any application performance issues all the way to the downstream to show where exactly the bottlenecks lie within the environment. And finally, it's used for planning of critical projects such as disaster recovery and cloud migration projects as well. So as I talked about, application dependency mapping is a very, very critical tool that can be used in so many different ways. It's a single tool which has multiple use cases, and as you can see from the section on the right, you can see it has like a lot of use cases such as asset management, root cause identification, disaster recovery planning, and so on. And I'll be talking about some of these in further detail as we go along with the presentation. So one of the first and foremost usages of application dependency maps is asset management and auditing. Over here, we all have come across like so many different organizations. We've all been a part of so many organizations where certain applications have been created 10 years ago, and nobody knows exactly what those applications do anymore. Documentation, it may have been created, but it's obsolete as soon as you create it, and this is really where application dependency maps can really help your organization. Application dependency maps would be able to discover any of your virtual and physical server assets and their interdependencies, and at the same time identify all those areas and identify all those virtual machines or servers that you didn't really know what it was doing. Second, identifying the root cause of any application degradations. Right? This is really critical because as you all know that application dependency maps can tell you exactly where the bottlenecks lie within the environment. Is it on the application tier? Is your network having some issues? Are you having like network latency issues that is causing like issues in the back end with your databases, or is it on your web server tier, and so on? And this is really where application dependency map can be used in order to identify the root cause of your environment. This is one of the most popular uses of application dependency map in this day. Being able to identify all your assets before you move to the cloud becomes very quintessential for the organization. It is also important because every organization needs to know all the different assets that could be moved, and all the different ports that it is using in order to move some of these applications to the cloud itself. Cost analysis and cost planning becomes very critical with regards to cloud migration. As we all know, cloud is not as cheap as it is advertised to be. It is important to make sure that it is optimized in terms of traffic accordingly. Any traffic that goes into cloud is generally free of charge, but coming out of cloud is where you pay a lot of money. So you can keep all that in mind as well. So the next is data center consolidation. So in a lot of organizations these days, instead of having multiple data centers in multiple different locations, they tend to basically bring all of them together and consolidate the data center. This essentially is created to help reduce the costs and basically can help in identifying areas to reduce cost and optimize the environment as well. While doing this, it is really important to understand and baseline some of the performances from before the application was moved to once the data center is consolidated, how the performance actually is with regards to the data center consolidation project. The other use case with regards to application dependency mapping pertains towards security. A lot of times we can, by drawing out application dependency maps, it is very easy for us to identify any application anomalies. And as we all know, modern day cyber attacks are really in stealth mode. They are no longer the smash and grab that they used to be. So being able to identify the single point of failures and identifying these multi-tiered applications can tell you what are the assets that could be compromised in case one asset is known to be compromised already. On the same lines, tracking application behavior anomalies is absolutely critical. As I already mentioned, most of the cyber attacks in this day and age are a smash and grab and not smash and grab and more on the stealth side of things. You can quickly see any minor deviations or any assets. For example, if your domain controller gets affected, there is a possibility that every single asset in your environment can get affected as well, because your domain controller essentially connects to every single asset in your environment. So it is very, very critical for us to know the application dependencies of all this as well. Another very important use case is to be able to optimize your configurations. Being able to identify and stay on top of all these application impacts and application performance configurations is very, very critical. A lot of times with our fast-moving IT organizations these days, everybody brings up new applications, when with containerization and all these newer technologies, new applications can be brought about on. And this really causes an IT nightmare a lot of times. And using application dependency mapping, knowing what the different changes are within the environment becomes very critical. And being able to import all this into a CMDB to keep track of all these assets becomes very critical as well. Finally, reducing technical debt is a very, very important aspect for most IT organizations. Being able to identify what are the different servers that actually have connections or in some cases, with using application dependency maps, you can find out dormant or underutilized servers, which you may not otherwise find as well. This way, when you can tie it down to like a special project like cloud migrations, and make sure that you retire some of these servers as you go ahead with some of these projects. Finally, thank you so much for listening to my presentation today. And if you have any questions, I'll be here for a few minutes. And if you have any questions for later, like, you can definitely visit me at. I'll be at the Vila booth 2029 if you want to come and ask me any more questions. Thank you.
Cool. We'll get started on this. So thanks everyone for coming. This is a session on PowerShell and the vCloud Availability 3 API. Real quick session. I'm just going to cover off these things. So a little bit about me. I'm in IT, originally from the UK, as you might tell from the accent, but now in New Zealand. The last point on there, I'm not a developer. I know enough to be dangerous. I can use Google, and most of what I've done and what I've shown is based on a lot of Google. So by any means, if any of you are developers and can help me improve what I put out there, then I welcome that. And the blog post I did at the bottom there on kiwicloud.ninja has a whole series of articles about the sort of setup and configuration of vCloud availability in a service provider context. So if you're interested in that, go check out that series. So what is vCloud availability? It's converged from sort of 3 separate VMware products that existed before. Availability itself, Director, Extender, Cloud-to-Cloud DR. And the basic intent is to allow you to replicate, protect and migrate virtual machines between service provider clouds, but also between customer on-premises environment and a VCPP provider, and vice versa. And it does all this in a self-service portal where customers can actually control that replication themselves. The third point there, it's definitely not a live migration tool. If you need a live migration tool, you're after HCX, not this. So it's not for live migration, but typically you can stage everything so it's just a power on, power off cutover. So you can do it very rapidly still. Similar to SRM, but it doesn't have all of the DR scripting and automation capabilities that SRM has just yet. That may come in future, but it's not there right now. So what does it look like? So from a service provider side, you deploy a series of OVA virtual appliances. If you're a tenant with an on-premises vCenter environment, you just need one appliance. And really importantly for a tenant, you only need outbound 443 to actually replicate. So in either direction, all you need is outbound 443. Makes it really easy for tenants to set up, and you can pre-stage disks, and it's got, most importantly for me anyway, a REST API that's actually really comprehensive. So some of the previous VMware products didn't really have an API that you could leverage, so you couldn't automate or orchestrate much with it at all. They've changed all that in vCAV. So the provider portal looks a bit like this. This is actually a snapshot from our, or one of our production environments as of a couple of days ago, and we went live with it in May this year. It was only released in April, and you can see we're already up above 400 customer VMs being replicated around the place. Every customer has just jumped on board and started using it in anger. So if you're a service provider looking at providing an easy self-service replication, I would definitely encourage you to check it out. And there's an API. So the official documentations at that link up the top there, there are a few caveats right now though. Not all the calls are documented. So there's some things that you can get out of the API that aren't actually in the documentation set, and I'll talk a bit about that. Some of the documented calls are actually incorrectly documented right now, and I've been filing sort of feedback against VMware for each time I find one, but I'm sure there are still working. And if you do need to find it, I'll show you where you can go to actually find the correct parameters if you find that a particular call doesn't work for you. So the API site looks like a typical VMware code API site. It's got all of the valid published calls listed in there, and you can see all the parameters that you need to provide. However, on each appliance, there's this C4 CLI PY file, which is the actual command line version of that API. And if you need to check the parameters for a particular call or API part and it's not working for you from the documentation, go and look in that file. It's got sections like this, which will actually tell you the exact parameters that you need to pass to the call. And like I say, sometimes they disagree with what's actually published in the Swagger documentation. This one in particular, where it says VCD user there, was originally published in the API docs as VCD username. So I couldn't work out for a couple of days why I couldn't get authentication working through the API. It was down to that. So what have I done? I've released a commandlet, actually a PowerShell module at that URI. It's called Power vCAV just because I had to call it something, and it works with Power CLI, so it kind of made sense. And it's very limited. It's got these 6 commandlets, but these are designed to enable you to be able to consume the vCAV API from a PowerShell script really easily and not have to worry too much about the authentication side of it. And it's particularly the authentication side that's quite problematic. So some examples of how you actually use this. So generally you'll use a Power CLI session connect CI server to connect to your VCD environment, and then you use the commandlet from the Power vCAV just to extend that session into the vCAV realm. And once you've done that, you can connect single site, multi-site, and get an authentication against the vCAV environment. And then once you are connected, you can do neat things like show me all of my vApps that are being replicated right now, and then show me all the data point items that are encapsulated in that replication, and then start basing your reporting or your scripts or your billing the returns that you get out of that. There's also a couple of example scripts that I put in the GitHub repository. So one is this summary report, and it just shows you per org how many VMs are being replicated and what sort of replications or protections those are. It gives you a total across everything. But probably the more useful one is the VM report. So this gives you details for every single VM that it finds through the API is being replicated. And right now there is no capability in the API to report how much network bandwidth is actually being used by replication. And that's something that service providers might want to use for billing purposes. So what this script does is takes the last number of replication history events, works out the time difference between them, works out how much data was transferred for each interval, and then gives you an estimate of, okay, per day you're transferring roughly this much data to keep this VM replicated. And that figure will obviously vary hugely based on what the VM's doing. And it is only an estimate, and I did put a note in the script saying for the first 24 hours after you set up replication, this number's going to be crazy wrong because it's got the initial full sync in that history, so it's going to be way out. So that was it really, like I said, really short and sweet. And I know the sort of audience for Power VCAV and vCloud availability is fairly limited in terms of service provider community. But I really welcome any suggestions for improving the module, bug reports, issues, even pull requests with your own enhancements and code to it. And hit me up on Twitter if you've got any of that or want to talk to me more about it. Otherwise, thank you.
Greetings. Welcome to my session at VMworld 2019 through the vBrownBag Tech Talk series. I want to thank the team here for having me on board, but I'm going to get right into the session here on intelligent validation of autonomous systems and sensors. This is part one. I plan on having the follow-on to this series as part of the vBrownBag series itself. Give you a little background on myself. I've been in the past working at VMware for 12 years, 3 years at EMC, and most recently at VirtuStream. I'm now working